Section 4.5 is about product to sum and sum to product identities. This is what you have been doing for the last few sections, learning identities. And so these are just some new ones. At the top of your worksheet, I have these identities listed. And so there's several of them. And we're just going to, in this section, practice how to use them. Okay? So the first example says to write each product as a sum or difference involving sines and cosines. So a product is something being multiplied, and so we need to either turn it into something being added, a sum, or something being subtracted, a difference. So what they turn into depends on what we're given. So in problem number 1, part A, we're given this product, the sine of 2t times the sine of t. So just look at your sheet and look where you see the sine of an angle times the sine of an angle, and I see it in the product of sum identities, and so it is this, and I will write it in a different color. This is the identity. The sine of x times the sine of y is equal to 1/2 times the cosine of x minus y minus the cosine of x plus y. All right, that's the identity. So all I did is said, what is the job I have to do? Turn it from a product being multiplied into either a sum or difference. I look at what I'm given, the product of two sines with different angles. So in this instance, I'm going to think of x as 2t and y as t. All right, and then I looked and said, well, what identity will work for me? And this will work. This will convert this product into this difference right here. So let's just start plugging things in. If I let sine of x be 2t and y be t, then this in the purple right here is going to equal to 1/2 times the cosine of x minus y, or 2t minus t, minus the cosine of x plus y, 2t plus t. All right, so this is equal to 1/2 times the cosine of 2t minus t is just t, minus, if I distribute the 1/2, 1/2, the cosine of 3t. And that is the whole answer right there. Let's go on to this one. The cosine of 2a times the sine of 3a. We're going to take this product, cosine of this angle times the sine of that angle, and turn it into either a sum or a difference according to which identity we can use. So right here, I'm looking at my identities and I see a cosine times a sine. The cosine of x times the sine of y, here's the identity. The cosine of x times the sine of y is equal to 1/2 times the sine of x plus y minus the sine of x minus y. Just like that, okay? So that's the identity I'm going to use. Now I'm going to let x equal to 2a and y is going to be 3a. So when I use this formula, this is going to equal to, I'll go back to the purple. This is going to equal to 1/2 times the sine of x plus y is 2a plus 3a, which is 5a. Minus the sine of x minus y is 2a minus 3a. 2a minus 3a is a negative a. Okay. Let us just look at this for a second. The sine of negative a. We have come across negative identities earlier in this chapter, and so we know that the sine of negative a is really negative sine of a, because this is an odd function, if you'll recall that. So what I'm going to do in this next step is I'm going to do two things. I'm going to distribute the 1/2 to each of these terms, and I'm also going to rewrite the sine of negative a into this. So it goes like this. 1/2 sine of 5a minus, okay, the sine minus 1/2, right? I distribute the 1/2. Sine of negative a is negative sine of a, negative sine of a. So the very last thing I'm going to do is multiply this negative times the negative and make that a positive. So I have 1/2 the sine of 5a plus 1/2 the sine of A. So I want you to watch or just pay attention to this. I did not set out at the beginning and go, this is what I'm given. I'm going to decide to turn this into a sum, and that's what it turned into. No, I looked at what I'm giving and I used the identity and I applied the identity, and whatever it turned into, either a sum or a difference, that's what it ended up being. So for the second one, it looked for all practical purposes like this was going to turn into a difference, but then once I used that, it turned into a sum. We don't worry about that. We just apply the right identity. Speaking of, I want to make sure that I'm not making a mistake on this video. I'm getting a lot more conscious of my mistakes. So let me just, I have worked this out earlier. So number one, the answer is supposed to be 1/2 cosine of t minus 1/2 cosine of 3t. Yes, I like that. Part B is supposed to be 1/2 sine of 5a plus 1/2 sine of a. I like that. Okay, let's go to number two. The directions for number two are write each sum or difference as a product involving sines and cosines. So what they've given us is a difference, and we're supposed to write it as a product, things being multiplied together. Okay. And also in B, we're given a difference, and we're supposed to write it as a product. So let's look at what we have to work with. And this time I'm using the second set of identities that I'm given, the sum to product identities. And so they are calling sum, even though they have a minus sign, they're calling that sums and differences is what they're including in the word sum. So, and the reason they do that is because when you have like x minus y, you can think of that as x plus negative y. That's why they're calling it using just that one term. All right, so we've given a cosine minus a cosine, and so use the identity that has the cosine of x minus the cosine of y. So here I'm going to write the identity down, and it is this, the cosine of x minus the cosine of y is equal to negative 2 times the sine of x plus y over 2 times the sine of x minus y over 2. All right, so here we go. I'm going to let x be 3t and y be t. So here we go. The black is the identity. The purple is where I'm continuing this problem. All right, so this is going to turn into negative 2. This equals, the purple equals to negative 2 times the sine of x plus y. 3t plus 1t is 4t over 2 times, I'm sorry, there's no minus, times the sine of x minus y. 3t minus t is 2t over 2. I'm just going to clean this up. This is equal to negative 2 times the sine of 2t times the sine of t when I divide that 2 in both of those. So that's my answer for 2a. Here's 2b. The sine of an angle minus the sine of another angle means I'm going to use the identity sine of x minus the sine of y, and it is equal to the sine of x minus the sine of y is equal to 2 times the cosine of x plus y divided by 2 times the sine of x minus y divided by 2. All right, that's my identity. Now I'm going to continue with the purple. So the purple equals to, I'll make a little space. This equals to 2 times the cosine of the first angle. X is going to be, just a second, there. X is going to be 3c and y is going to be 7c. All right, so we have 2 times the cosine of x plus y over 2, or 3c plus 7c is 10c over 2 times the sine of 3c minus 7c is a negative 4c over 2. All right, let's clean this up. First thing that I see I can do here is 2 goes into 10 5 times. So this is going to be 2 times the cosine of 5c. right here, 2 goes into -4, -2. So really, this is, just our ThinkPad over here, the sine of -2c. But I'm going to use that same negative identity since sine is an odd function. This is really negative sine of 2c. All right. I'm going to say this is times negative sine of 2c. And then lastly, I'm going to say negative times 2 is a -2 cosine of 5c sine of 2c. And this is B for number 2. Let me just check my work real quick. I'm supposed to get up here, number 2a. I was supposed to get -2 sine of 2t sine of t. I like it. For part B, I was supposed to get -2 cosine of 5c sine of 2c. I like it. Okay, let's do it with angles that we know. Okay, so here are the instructions for 3. It says evaluate the cosine of 15 degrees times the cosine of 75 degrees exactly. Use an appropriate identity. All right, so exactly means no calculator, okay? So let us do it exactly. Let's evaluate this cosine of an angle times the cosine of angle. How can we evaluate that? Well, look at the identities you're given. Look at the first set that you're given, and this falls into the cosine of x times the cosine of y. And so this, it would be the cosine of x times the cosine of y. That's what this fits into, where x is 15 degrees and y is 75 degrees. So the cosine of x times the cosine of y is equal to 1/2 the cosine of x plus y plus the cosine of x minus y. All right. So let's evaluate this and see what happens. So in the purple, this is where it's equal to. I have a silly, my dog has the silliest bark I've ever heard. So if you're hearing that right now, it's silly little bark. Okay, here we go. Cosine of, oh, it's equal to. This is equal to, so we say the cosine of 15 degrees times the cosine of 75 degrees is equal to 1/2 bracket the cosine of x plus y. Well, 15 plus 75 is 90 degrees, okay, plus the cosine of x minus y, or 15 minus 75, which is -60 degrees. All right. Now, just for a second, let's recall about the negative identities for cosine. If we have the cosine of negative x, this is just equal to regular old cosine of x, because cosine is an even function. So what that means is that this is equal to 1/2 the cosine of 90 degrees. Let me distribute the 1/2 times 1/2 the cosine, not of -60 degrees, but of 60 degrees, if you want to think of it that way. And I do. So I have to come up with the exact answer. So I'm going to pull out my unit circle. So get your unit circle ready for this, and for the next, when we get into 5.1, you're going to need it for the next videos when we go into inverse trig functions. So have it handy. So here's my unit circle. Let me try again. I'm looking at 90 degrees. Okay, 0 degrees, 180 degrees. This is 90 degrees right here. This is the point on the unit circle. The coordinates of this point are 0, 1, meaning that 0, the x-coordinate, is the cosine of 90 degrees, and y, the y coordinate is the sine of 90 degrees. We are after the cosine of 90 degrees, so this is a 0. So this is equal to 1/2 times 0, the value 0, plus 1/2 times whatever the cosine of 60 degrees is. Well, 60 degrees is here, and the unit circle, the coordinates of this are, let me see, 1/2 square root of 3 over 2. The cosine of 60 degrees is the x-coordinate, which is 1/2. 1/2. So the exact value is going to be 1/2 times 0, which is a 0. 1/2 times 1/2 is 1/4. So 1/4 is the exact value for cosine of 15 degrees, cosine of 75 degrees. I'm going to break this into 2 videos. I'm gonna do the last three problems on this worksheet in part two.